So let's look at an example now. I want to find the direction that maximizes the rate of change of f of x, y, z equals the square root of x plus x, y, specifically at this point. So I know that the maximum occurs in the direction of del f. So, and of course, del f is equal to the vector partial with respect to x, partial with respect to y, partial with respect to z. Okay, so let's just go ahead and find these. So the partial with respect to x is going to be equal to, obviously, 1/2 times x plus yz to the negative 1/2, which is going to be simply 1 over 2 times the square root of x plus yz. Now, again, I can see that this is going to show up everywhere, right? Every one of these partials is going to have this. The denominator is what I'm making reference to. The numerators may be different. Well, the numerators will be different, but everyone's going to have this denominator. So I need to evaluate this at 1, 3, 1. So this equals 1 over twice the square root of, well, 4. So this is going to be a fourth. So I know this is going to be, this 4 is going to show up in every one of these partials. So the partial with respect to y is going to be 1/2 x plus yz to the negative 1/2 times, but with respect to y, I'm going to have z in the numerator. So if I evaluate this at 1, 3, 1, 3, 1, z is 1 in the numerator. This is still 4 in the denominator. So this, again, this is 1/4. And with respect to z, this is going to be, well, it's going to have y in the numerator. So I'm going to end up with y over twice the square root of x plus yz, evaluated at 1, 3, 1. This time y is in the numerator, so I'm going to end up with 3/4. Therefore, the max occurs in the direction of 1/4, 1/4, 3/4 at the point point, there we go, 1, 3, 1 on the surface. And I can add to that idea that it will have the magnitude square root of 1/4 squared plus 1/4 squared plus 3/4 squared. So this is going to be root 11 over square root of 16, which is obviously 4. So I've got, I really need to write that a little bit neater. Root 11 over 4. So this is the direction of the maximum ascent, if that's what I want to think about it, off that surface. And that's the magnitude of the ascent.